Okay, so now this is a sort of a new twist. The inner integral has a variable as the limit. Okay, so let me observe something. The inner integral, the limits are x, are functions of x, which is the variable of the outer integral. Okay, it could not go the other way around. We could not have the outer integral have limits that are functions of the inner variable, but the inner integral can have functions of the outer variable. And when we get in 2 lectures from now, not lecture 28, but lecture 29, we'll actually see where things like this come up. But for now, let's just do the thing that seems like it should be the thing that we should do. So we're going to do like we did before. We're going to write the integral x equals 0 to 1, put brackets, and then do the integral y equals x squared to x squared y dy dx. Now remember, as far as y is concerned, x is a constant. So if you just look at the integral in the brackets, x isn't a variable. As far as y is concerned, it's a constant. So this is going to be the integral x equals 0 to 1. I'm going to factor out the x squared. Now this is going to be the integral y equals x squared to x y dy dx. This is equal to the integral from x is equal to 0 to 1, x squared. Now for the brackets, the antiderivative of y is y squared over 2, so I'll go on ahead and write the 1/2. And then this is going to be x squared minus x to the power of 4 dx. And so this is 1/2 x equals 0 to 1, x to the power of 4 minus x to the power of 6 dx. And this is 1/2 times, okay, the antiderivative of x to the power of 4 is 1/5 x to the power of 5. The antiderivative of x to the power of 6 is 1/7 x to the power of 7. And we're integrating from x equal to 0 to x equal to 5. So the integral of x to the power of 4 from over 0 to 1 is going to be 1/5. The integral of x to the power of 6 is 1/7. So this total is going to be equal to 1 over 70 times 2. So that's 2 over 70. So this is 1 over 35. Okay, and you'll notice here that I did the exact thing I told you not to. That's the second time in this one video. So it should be dx dy instead of dy dx. So again, I'm just going to write the outer integral, y equals 0 to 1. The inner integral is in terms of x's. So I don't care, as far as x is concerned, y is a constant. So I'll pull the y out. This is the integral from x is equal to y, square root of y, x squared dx dy. So now this is equal to the integral y is equal to 0 to 1 y. Now the antiderivative of x squared is 1/3 x cubed. So I'll divide by the 3, and then it's going to be y. So I'm going from, so it's x cubed, going from x is equal to y to x is equal to y squared. So this is going to be y to the power of 3/2 minus y cubed dy, or this is going to be equal to 1/3 times the integral y equals 0 to 1. So y to the 3/2 times 1 is y to the 5/2 minus y to the power of 4 dy. Okay, so let me write the 1/3, and we'll do each one of these integrals. So the antiderivative of y to the 5/2 is going to be y to the power of 7/2 divided by 7/2. So this is 2 over 7, and we're just going from y is equal to 0 to y is equal to 1. So 1 to the power of 7/2 is 1, minus y to the power of 4. Now the antiderivative of that is y to the power of 5 over 5. So this is going to be 1/5. Okay, and if we simplify, I'll have the 1/3 times 1 over 35, and then 10 minus 7. And this is equal to 1 over 35. Okay, and so for this problem, these two integrals happen to be the same, and we notice that there's something similar, that the integrand is the same, and the limits are different, but they look kind of similar. And in the next video, we're going to look at that a little more.